Now students, we are going to discuss about the oxidation state. Nowadays, the term oxidation state is used frequently. Now, what is the oxidation state? Oxidation state is the charge acquired by the atom of an element on the basis of electronegativity of other atoms in a molecule. That means in a compound, we will have two or more than two atoms can be present, right? Now, in the molecule of that compound, what will be the charge which will be acquired by the atom of an element with respect to the other element on the basis of the electronegativity, right? So here now we are going to consider the example of the OF2 and Na2O. To just understand the concept of oxidation state, we are considering OF2 and Na2O. We will take it one by one. So first let us take this example OF2. Now in this compound students OF2, right, if we just write down the configuration of oxygen, so what it is, I'm just writing the valence shell, it is 2s2, 2p4. And what is that of fluorine? It is 2s2, 2p5. So you can check the electronic configuration. Here it is just visible that fluorine, it has got the 7 electrons in its outermost shell, whereas in oxygen has got only 6 electrons in its outermost shell. And definitely the nuclear charge, right, of fluorine is going to be very high. So if we just compare the electronegativity of oxygen and fluorine, so fluorine being they having greater nuclear charge with respect to oxygen will have higher electronegativity. So on that basis, right, so here it only needs one electron, but oxygen one atom has a tendency, right, this oxygen here, right, it is 2s2, 2p4. So if it just get its one electron shared with the other, what will happen here? It will get the half-filled configuration and the fluorine will get the stable configuration. So one of the oxygen atom, right, it is just getting its one electron with this fluorine atom, right? So we are getting here how much? For one fluorine atom, sorry, for one oxygen atom, right, we need how much? 4, it's 5 and 6, right? 5 and 6, that means here that we are here for each oxygen atom we will require 2 fluorine atom so that a, a stable molecule is being formed, right students? So if you just check the electronegativity of oxygen and fluorine, I'm repeating again, which one is more electronegative? Definitely it is fluorine which is more electronegative than oxygen, right? So in the formation of OF2 molecule, each of the two fluorine atom shares one electron with oxygen atom, and oxygen atom shares 2 electrons with fluorine atom, right? So again I'm saying that two fluorine atom are going to share one electron with oxygen atom, and oxygen atom shares 2 electrons with fluorine atom. As a result, since each fluorine atom is sharing only one electron, so the fluorine will show the oxidation state of -1, and oxygen will be showing the oxidation state of +2, right? Now just come to the next compound, it is Na2O, right? We know that the configuration of sodium, right? So it is going to be neon, and then we have 3s1, right? This is the configuration of sodium. And in oxygen, we know that oxygen has got the configuration of outermost shell. It is 2s2. We are writing it here as helium condensed form. It is 2p4. Now student, in this compound, that is sodium oxide, if you just check the electronic configuration of neon and that of oxygen, right? So what you will find that for the formation of Na2O, oxygen being more electronegative. You will see now if we compare the electronegativity, sodium and oxygen is more electronegative, accepts the electrons, one from each of the two oxygen atom, and thus the oxidation state of oxygen is how much? It is -2. If you students again compare the electronegativity of sodium and oxygen, you will find that the electronegativity of oxygen is more than the sodium, right? So the oxidation state, which is based on the electronegativity, right, of the other atom which is present, so it will be for sodium, it is going to be +1, right, because two of the sodium atom are going to lose its electron to oxygen, and oxygen is going to accept the 2 electron and it will get the charge of -2 on it, right students? Hope so this is clear to you. What is oxidation state? Oxidation state is the charge which will be acquired by the atom, right, on the basis of the electronegativity of the other atom which will be present. If you see here in this case, you can see that oxygen is getting the oxidation state of how much here students? It is +2. But in this case, second example, you can see that it is showing the oxidation state of -2. Right? So why it was here +2? Plus why? Because it was bonded to the more electronegative element there, chlorine, and in this case it is bonded to the electropositive element. So with its respect, it is going to get the negative charge, right? And the one sodium atom is going to lose one electron or will to the oxygen atom. So it is getting, for per atom it is how much? +1, right students? And in this case, you can see that for the fluorine, right, it is for per atom it is going to be how much? It is -1. So this is about the oxidation state, right? Now the S block and the P block, which are the transition elements, they generally they show the valence electrons, okay, valency, right, which is generally 1, and if there is any variation, right, it will be variable. If it is there, maximum it can show 2 or 3. But we have got the transition elements students, D block elements and the F block elements, they show variable oxidation states, also, and variable valency also, right? So that is about the transition elements and the F block elements, right? So whereas the normally the representative elements, they show the valence electrons, valency, which is generally fixed, and if there is any variation is there, it will be only few variable oxidation state will be possible. For example, if we take oxygen, right, so generally oxygen we have got the valence is 2 here, but sulfur is there which can extend its valency to 4 also and 6, just because of the availability of the d orbitals, right? So this is there about the oxidation state, and student, these oxidation state definitely affects the chemical properties of the elements, right, in a periodic table. So student, just go through it very nicely, that how the oxidation state depends upon the electronegativity of the other element in the molecule.